evaluate integration over 1 to 2, integration over 0 to 4, 2xy dy dx. So before starting the exercises, you need to understand which are the limits of y, which are the limits of x. So integration over 1 to 2, integration over 0 to 4, 2xy dy dx, which is equal to, what we do? First we mention what is the limit of x, we mention which are the limits of y. So here in this particular integral, y is inside, x is outside. So the inner limit of y, these are the limits of y. So let us write y is equal to 0 to 4, 2xy dy. Then the outer limit of x, so I write for x is equal to 1, to x is equal to 2 dx. Students, you don't make any mistake. First we always mention which are the limits of y and which are the limits of x. So this is equal to, now first we integrate with respect to y because the inner limit of y. So first we integrate with respect to inner integral, then we integrate with respect to outer integral. So here it is 2xy dy. I have to integrate with respect to y. When do we integrate here with respect to y? It is assumed that x is constant. So 2x is the constant quantity. Integration of y is y square divided by 2. And then the limit y is equal to 0 to y is equal to 4 dx. So this is equal to integration x is equal to 1, 2x is equal to 2, 2x. Here you can cancel out 2 and 2. So let me write only x multiply by y square. But here what is the limit of y? Y is equal to 4 to y is equal to 0. So this is 4 square minus 0 square dx, which is equal to integration x is equal to 1, 2x is equal to 2, 4 square is 16 minus 0. So this is 16 into x dx. Now this is our usual integration. 16 is constant, we will take it outside. X has integration x square divided by 2 from x is equal to 1 to x is equal to 2. And so this is equal to 16 divided by 2 is 8, x square, that is 2 square is 4 minus 1 square is 1, and therefore the answer is 24. What is the left hand side? Integration over 1 to 2, integration over 0 to 4, 2xy dy dx. I repeat the example again. 2xy dy dx. First we integrate with respect to y. So you observe when we integrated with respect to y, after that everything is in terms of x only. You just observe here, everything is in terms of x. Then we integrate with respect to x, we substitute the limit, and the final answer is always the number. Let us discuss one more exercise. integration -1 to 2 integration 0 to pi by 2 y into sin x dx dy. In this example, what is happening? The inner limit of x, outer limit of y. So first we integrate with respect to inner integral, which is x, so with respect to x. Then we integrate with respect to y. So in the solution, first we mention what is our x and which are the values of y. Y into sin x dx dy, which is equal to integration from -1 to 2 from 0 to pi by 2 y into sin x dx. Switch off. Then dy. So here x is interior, so x is equal to 0 to pi by 2, y is equal to -1 to y is equal to 2. So this is equal to integration y is equal to -1 to y is equal to 2. Here, when do we integrate with respect to x, y is assumed as constant, so y as it is. Now what is the integration of sin x? The integration of sin x with respect to x is minus cos x. From x is equal to 0 to x is equal to pi by 2 dy. Let us substitute the values first. So this is y equal to -1 to y equal to 2, y into. This is minus cos pi by 2 minus sin for lower limit minus cos 0 dy. So this is equal to integration y is equal to -1 to y is equal to 2 cos pi by 2, which has value 0, cos 0, which has value 1, so minus plus 1, and therefore this is just y into dy. And you know what is the integration of y into dy with respect to y is y square by 2 from y is equal to -1 to y is equal to 2, and therefore integration over 1 to 2, integration over 0 to pi by 2 y into sin x dx dy is equal to 1 upon 2 into 2 square is 4 minus 1 square is 1, and this is equal to 3 divided by 2. So look at these two examples again. Here we had given dy dx. So first we integrated with respect to y, then we integrated with respect to x. In this example, we had given dx dy. So first we integrated with respect to x, and then we integrated with respect to y. The next exercise, evaluate double integration over region R 6y square minus 2x dA. And what is R? R is the region bounded by 0 to 1 and 0 to 2. Now see, here what is going on. As I told you that this is very small rectangle, so this dA can be represented by either dx dy or can be represented by dy dx. That means you can evaluate this quantity double integration over R 6y square minus 2x dA by two different aspects. This integral, say this is I, so this is equal to, either you can write double integration over R 6y square minus 2x dy dx, or you can write down this as 6y square minus 2x dx dy. Whenever you are writing it is dy dx, you need to be careful that your inner limit is of y and outer limit is of x. Whether here 6y square minus 2x dx dy, so inner limit is of x and outer limit is of y. Clear? Now which are the values of y and x? So here y is from 0 to 2, so that I am writing here y is equal to 0 to y is equal to 2. Same way y is equal to 0 to 2, and x is given 0 to 1, so I am writing x is equal to 0 to 1 and x is equal to 0 to 1. Right. Now let us integrate both the quantities. Let us concentrate on this first. What we have to do? First we integrate with respect to y. So whenever we are integrating with respect to y, x is equal to 0 to 1. 6 is constant. Integration of y with respect to y is y cube by 3 minus 2 is constant. Keep in mind we are integrating with respect to y, so x as it is, integration of 1 is y, with the limit y is equal to 0 to y is equal to 2 dx. Here this 3 can be cancelled out, and so this is equal to integration x is equal to 0 to 1. This is 2y cube minus 2y from y is equal to 0 to y is equal to 2 dx. This is 2xy. Now let us substitute the values of y when y is equal to 2. So 2 cube is 8, 8 into 2 is 16, minus y equal to 2, so this is 4x, minus sign for lower limit, and I write the values. When y equal to 0, this is 0, y equal to 0, this is 0, everything will be integrated with respect to x. So this is equal to integration x equal to 0 to 1, 16 minus 4x dx. What will be the integration? So this is 16x minus 4x square by 2 from x is equal to 0 to x is equal to 1. So this is equal to, when x is equal to 1, this is 16 minus, these 2 will be cancelled out. So 16 minus 2, minus sign for lower limit. When x is equal to 0, this is 0 minus 0. And so the final value, what is I? Is 14. Now let us complete the another part. Here what we have to do? We are integrating with respect to x first and then with respect to y. So what will be the integration with respect to x? Can you tell me? 6y square as it is, integration is x, minus 2x square by 2, which is the integration of 2x, x is from 0 to 1, dy. Substitute the values of x, y is equal to 0 to y is equal to 2. You can cancel out 2 and 2 here. Keep in mind we are substituting the values of x. So 6y square, x equal to 1 minus x equal to 1. This minus sign for lower limit, and I am writing for x equal to 0. So this is 0, this is 0, everything with respect to y. So what is this? Integration y is equal to 0 to y is equal to 2, 6y square minus 1 into dy. So what is the integration here? This is 6 y cube by 3 minus y, from lower limit is y equal to 0 to upper limit y equal to 2. We can cancel out these 3 here. And when do we substitute the values? Y equal to 2, so 2 cube is 8 into 2 is 16, minus y equal to 2, minus sign for lower limit. When y equal to 0, this is 0, and so the answer is 14. 16 minus 2. Let us repeat the whole exercise again. 6y square minus 2x dA. dA is very small rectangle with the length dx, width dy. So either you can write it is dx dy or dy dx. Suppose we are following dy dx, then we first integrate with respect to y, then we integrate with respect to x. Suppose we are following dx dy, then first we integrate with respect to x, then we integrate with respect to y. Whatever method you follow, the answer is always same, 14. The more example we shall discuss in the next